Welcome, everybody. So let us review what we learned so far. ODE, review. We learned that a differential equation is an equation including or containing the derivative. Well, when we're talking about a differential equation, that depends on what type of function you're dealing with. So if you have y equals to f of x, so in this case, x is independent variable and y depends on x. Remember that we defined the derivative of this function, dy over dx, as y prime. If you open different calculus books, you might see this y prime is also represented by y with a dot on top of it. The second derivative of y with respect to x squared, with respect to x, is y double prime with y, two dots on top of it. But for the rest of the variables, instead of putting dots or using prime, we use numbers in parentheses. So when you're talking about the third derivative, you put 3 in parentheses. What's the meaning of that? It means that you took the third derivative of y with respect to x, and you continue this process. We also learned that if you're writing a differential equation, we have a normal form. We have a general form. So for y equals to f of x, a differential equation has an order. What is the order? The order of a differential equation is the order of the highest derivative appears in that equation. The order of a differential equation is the order of the highest derivative in the equation. Well, okay. So if we know the order of a differential equation, we can represent it this way. An nth order differential equation is denoted by, well, f, which represents a relation, a connection between x as independent variable and y, which depends on x, and the derivatives of y. The first derivative, the second derivative, and since it's an nth order differential equation, we're going to stop at y n into parentheses, which means that you have the nth derivative of y. This is the nth derivative. Very well. We said that we can classify differential equation based on the being linear or nonlinear. This is important for us. Why is that? Later on, we see that when we're representing the solutions of a differential equation, we can classify those based on linearity of the differential equation. So what was the definition of a linear differential equation? Again, recall that a differential equation is called linear if it is linear in y and its derivatives. What's the meaning of that? It means that we can write the differential equation this way. What way? It's going to be like this. First of all, you're going to have addition between the derivatives and y as the variable or as the function in the differential equation. There is no multiplication between the derivatives and y. The very first term is in terms of x times the nth derivative of y. Plus, so note that the operation that we are using is addition between the derivatives. Plus a sub n minus 1, another term in terms of x times the nth minus 1 derivative of y. Again, note the operation between the derivatives. Plus the middle terms, then you have a term in terms of x, a sub 1 x, the first derivative, plus a sub 0 x times y, and on the other side you might see a constant, you might see a function in x, but it is in terms of x. So the operation is addition between the derivatives of y and also y itself. These are all addition. That's why we said that, hey, if you see multiplication between the derivatives, if you see multiplication of y and the derivatives, if you see functions including y, those count as nonlinear differential equations. Very well. So give us some examples of linear ODE and nonlinear ODE. So before going over the examples, whenever you see these in an ODE, it means that you have red flags. It means that it's nonlinear. So note that. Note that if y equals to f of x, the following makes an ODE non-linear. If you see the multiplication between y and y prime, if you see the multiplication of y and itself, if you see multiplication of y and, I don't know, the third derivative, if you see any multiplication of y and its derivative, or even if you multiply the derivative by itself, it makes the differential equation nonlinear. If you see, for example, sine of y, if you see e to the y, and anything of this form makes the differential equation nonlinear. You cannot have these things in a linear differential equation. Differential equation becomes nonlinear. For example, let's take a look at these examples together. Example 1. Here I have this guy. I have the third derivative of y minus 5x y prime equals to e to the x plus 1. Is this linear? Okay. Do we have the definition for linear differential equation? Yes, the definition is just right here. It says, hey, I have some x term multiplied by the derivative plus another x term multiplied by the derivative plus the rest of the terms. And I follow this. And finally, I need to see an x term multiplied by y equals to a constant or a function in x. Take a look at this. Can I compare these two? Of course. This is my third derivative. I don't have any problem here. This guy is good. It's just the third derivative of y. So I'm going to the next addend. Here I have an x term multiplied by the derivative. Of course, there is no problem here. I don't see any multiplication between y and y prime. I see x multiplied by y prime. As you see the definition, you need to have a term in x multiplied by y prime, so you're good. I don't have a sub 0 x times y. That's fine. That guy must be 0. 0 times y is 0. So that's why you don't see it here. On the other side, you must have function in x. Do you have a function in x? Of course, this is my g of x. So what's the meaning of that? It means that 1 is a linear ODE. It is linear. If I ask you, what is the order is the highest order derivative in this equation. So the order is 3. Well, you might say, I can identify independent variable, which is x, and dependent variable, which is y. X and dependent is y. This is the very first example. Okay, another example. Number 2 says, well, what do we have here? We have t times the second derivative of y plus t squared, the first derivative of y, minus sine of t times square root of y equals to t squared minus t plus 1. Okay. So the t that you're seeing here can be replaced by x. It doesn't matter. Here it says that, hey, y is a function of t. Y is f of t. Let us compare this with the definition of linear differential equation. But here, if you notice, you don't have to check each one of these addends. Why is that? Because here, you don't have y. You have square root of y. This square root of y makes this equation not linear. This is your red flag. Because we have square root, it is not linear. So when you're talking about t, it means that this definition becomes like this: a sub n t, a function of t times the n derivative, plus another function of t times the derivative, another function of t times the derivative, another function of t times the derivative equal to g of t. So you can change the free variable. That's absolutely fine. What's the meaning of that? It means that your function depends on t. So if you compare these, you have an of t, which is your t. We're good with that. We don't have any problem here. This is in terms of t. It's not in terms of y. So we're happy about this. That's absolutely fine. Multiplied by the derivative. That's good. Here you have t squared, a function of t. T can be anything. Here we're good. Times the first derivative of y. We're good. We're happy here. Here you have a function of t. That's absolutely fine. I don't have any problem with function of t. Take a look at this. As long as I have a function of y, that makes it nonlinear. Very good. So we talked about linear differential equation, nonlinear differential equation. Now the question is, what about the solution? Throughout this course, we're going to learn different methods of solving differential equations. It's going to take a long time to represent each solution for different types of differential equations.